is Raj Singh, and I'm a product manager on the IRIS Data Platform. And I'm also a product manager for our work on Visual Studio Code. So it was natural for me to come here and talk to you about embedded Python with object script development inside our flagship IDE, VS Code. You may also want to check out any one of the other 3 sessions we have for developers on this topic. And I'm sure they will cover a lot of interesting angles that I am not going to have a chance to get to here. So I have a lot to talk about. There's a very exciting new feature in IRIS. And so let's just jump right in. Okay, so VS Code is a great place to work on Python code. And with our object script extension, we made a great place to work on object script code as well. So naturally, you're going to spend a lot of time in Visual Studio Code doing your development work, hopefully in the future. So let's get started on how to do that. So I'm going to create a Python file here, and I'm just going to call it iris embed.py. Okay, and show you how we're going to do this. First, we're going to import sys. Now we need to import the Python sys package because we need to change the Python path so that Python is aware of our special Python packages that we've developed. Most important of that is the iris library. So after we set the path to various directories in my iris distribution, we can import iris. So let's just see how that works. Make sure it works. So I'm going to actually, I need brackets around that. Let's save that. Right in Visual Studio Code, you can open a terminal window so you don't have to switch back and forth. It puts you right into this directory. Now I'm going to run this file, Python iris embed.py. So you'll see here, I printed out this module just to show it worked, and we are finding it nicely. In my iris installation, lib Python 3.9, site packages, iris.py. Great. So now we continue and write some real code. So what you're usually going to do to start off any kind of work is query the database. So I am just going to run a SQL select statement using my iris object. It's a very simple one. Here we're going to select 10 records from the data.titanic table. We're going to get back all the properties for it. And let's loop through those. Print out data for that row. Now when I run this, I get a listing of 10 rows, as you can see. Now one thing you might notice is that there are brackets around each row. Well, that is because Python returns this data as a list. So let's print the type after we do each row, and you'll see the class of each line is a list, which gives you pretty easy access to every item in the list, like so. So now, after printing the type, we're going to print the value in index number 4. So let's just look at the last item here. We have right here highlighted class list, and the 4th indexed item is Nasser Mrs. Nicholas. So you'll see here, if I go 0, 1, 2, 3, 4, that's the value. Great. Now I'm going to show you one other thing. So, access to data we've always been able to do. That's not so exciting. Doing it in Python is great if you have better Python skills in ObjectScript. But what's really powerful is when you're able to leverage Python packages like, for example, Pandas. Excuse me. So let's run that same exec statement, but now we're going to get back all the data. Select star from data.titanic, and this is how easy it is to put that into a data frame. A lot of information about Pandas data frames out there on the web. Read it. It's an amazing, amazing package for manipulating data and data exploration. Let's just see. One command I like to use when I see a data set for the first time is describe. Run that, and you'll get a terrific list of exploratory statistics on each property in the data set. Count, mean, standard deviation, min, and some quantiles, and the maximum values. Very useful. So now let's take what we've learned and put it into a full frame. I've been wanting to do this for a long time and haven't had a great way to do it. And what I've wanted to do is be able to have a quick visualization of my data, just a quick overview of the shape of it, what the properties are like, what the values of those properties are like, if the data looks of a high quality, accurate, what's the spread of values, that kind of thing. Something you always want to do before you dive in and make use of a data set. Make sure it is very healthy. So, as I said, I haven't been able to do this in an easy way for a long time until we got embedded Python and the ability to use pandas close to the data. So I'm going to show you two things. One is a quick overview of how to put together a full web application backed by REST services, and how that pandas, how the methods in pandas are so valuable. So let's dive in. I'm going to go very fast, but you have the GitHub repo right here, and you can download the code and play with it. And please definitely contact me if you want any help or if you have any questions. I'd be more than happy to walk you through any tough spots. So here's the GitHub repo. Let's clone this code. Okay, copy the URL, open PowerShell, git clone, at repo. Right away, I'm going to go into the app directory. This is the front end application. Oops. First, I have to go in Iris Data Explorer, app, and I'm going to start installing all the NPM packages for that front end React application, because that takes a while. We can talk about the data as we go. Okay, so let's minimize that. Switch over to Visual Studio Code. Done with this. So let's open. So first of all, there are two things I do not have time to talk about, which is how to connect VS Code to your instance of Iris. And I also don't have time, unfortunately, to talk to you about how to set up a RESTful web application. But let's just assume that has been done, and we have a REST endpoint of /API/Explorer. And that API is hooked up to this explorer.service.class. And here it is. So I'm going to go through this very quickly, the ObjectScript pieces, and dive a little bit more deeply into the embedded Python pieces. First of all, the ObjectScript extension gives you this great little outline of your class file with properties, methods, and even this Xdata section down here, the URL map. So just really quickly, this application is driven by 3 REST APIs. First one is /explore/datasets, which gives you a listing of dataset names. And then we have explore/:dataset, which is a place for a variable name gets substituted in here. So the dataset name/props will give you a list of all the properties of that dataset and the types of data contained in that property. Finally, the exciting one, /explore dataset name, property name, and property type, calls the explore method, which is where all the work gets done to generate the descriptive statistics for that property. So I'll quickly go through each of these 3. Get datasets, all in object script, very simple. We query information schema.tables to get some basic information back about all the tables in the namespace. And we're interested in base tables because we don't want to show system tables here. We run a SQL statement to get back that data. We put it into a dynamic object here, looping through each row. And then we translate that dynamic object into JSON, send back the result. User gets a nice listing of dataset names. Back here, next thing the user is going to want to do is click on a dataset and get a listing of the properties and the descriptive statistics. We do that in 2 steps so that the user doesn't have to wait for anything to show on the screen. First call, explore dataset name/props, returns all the property names in the dataset and the data types for those properties. And then after that's displayed, we go back and make multiple calls to this URL to get all the descriptive statistics. In here we'll do explore dataset name, property name, and type. And that ends up calling a method called explore. And explore is really just a wrapper so that we can call Python method explore_p to get the real information we need and send it back to the client. Explore_p is where the magic happens. So you'll see it looks like a normal class method with properties passed in, but you'll see here at the end, in brackets, we have language equal Python. So everything in this class method is actually Python code interpreted by the embedded Python interpreter. And on the client side here in VS Code, syntax colored perfectly as Python. So we have to import IRIS because we need access to our IRIS database. We're going to import Pandas because that's the library we're going to use to really easily generate descriptive statistics. And then we're also going to use the JSON package to translate those statistics into JSON very quickly and send it back to the client. So there are multiple data types, obviously, that you could have, and each one would have a different useful visualization of what's in that data type. Boolean, for example, you only have 2 values to work with, true or false, yes or no. So you're going to do different things than you would with a continuous numerical variable, where you'd want to see the distribution of values and potentially look for, a normal distribution or something where all the values are up on the right, or they're all, high or low, or there are a lot of outliers, things like that. That's the kind of thing you want to look at with your exploration of the descriptive statistics. So if we have a Boolean data type, we'll basically do a select so that we can count them up and return how many of each there are. If it's not a Boolean, we're gonna select that data into a data frame, a Pandas data frame here. And that's going to be very useful to run descriptive statistics because you have this great describe command built in. And if you don't know what describe command does, go look it up. It's really a great tool. groups bins your data by default into a few different quantiles, shows you min max, and that kind of thing. So we'll quickly do a check. First thing we do is make sure there is data in this property. If there are no records available, if the count is 0, we just have to return because we can't do anything more. I have not done anything interesting with properties that are all strings. If you have a great idea, please contribute to this GitHub repo. I'm very interested in seeing what visualizations would be useful for that type of data. But what I did do is go and do something useful with numerics, because that's the power of Pandas. So if we have a numeric property, we're going to take the data frame for that property, and we're going to run value counts, which very handily bins the data into however many bins you want. In my case, I'm going to put into 10 bins of equal numbers of. I'm going to put it into 10 bins. And what Pandas is going to do is give you the low and high value for each bin and the count, and return it. So here we just put that in JSON and return it to the client. Okay, so let's switch over and see if our application is ready to run. So I'm going to just open a terminal here, right in VS Code. I'm going to go into the app directory, and I am going to start up my application. Command yarn start. So it's going to take a few seconds to compile this, package it up for web delivery. And then it's going to start a little development web server and publish my code out on. So when we start up the application, you'll see those data sets returned. I'm going to reload this so that you can see some of the URL calls going on there. You'll see right here that I called /API/Explorer/Explore datasets, which returned me this simple JSON, and the React app was written to translate that into this nice looking thing. I'm going to click on this dataset, data.titanic, and you'll see a number of other calls being made here. As I said, the first call we make is going to return all these property names. And then we go back and fetch all the exploratory statistics for each property. Let me close this so you can see those better. So ID isn't very interesting. That's not really something that is very amenable to descriptive statistics. And as I said, we don't do very great stuff with strings yet. Out of 891 passengers on the Titanic, they each had a unique name, unsurprisingly. So that's not a very interesting visualization. But the sex, male, female, that is interesting. So we had 891 passengers, 2 unique values. The top one was male, had 577 male passengers. Here's a pie chart showing that proportion. Age is another nice histogram. Minimum age 0, maximum age of 80. The mean was 29.679 and standard deviation of 14.536. And you'll see the distribution here visually. Notice we have a count of 714, so there was some missing data there. We didn't have ages for everybody. And it goes on like that. So you can imagine how useful that is in a second to see all this information about the properties of your data set. And this was very hard to do before we had embedded Python. So I hope this gives you a small idea of the possibilities available with Python close to your data. And not only with Pandas, but in all those libraries that you may have wished you had access to next to your IRIS data. So thanks for joining this session, and I can't wait to see what you build.